Let us say we have to construct a Murray machine that accepts set of or that takes set of all binary numbers, which means sigma equal to 0 comma 1 and produces residue modulo 3. What does it mean is, if I take a binary number and if I divide with 3, whatever is the remainder that should be printed, which means the output has to be remainders when any number is divided by 3. So what are the possible remainders? 0, 1, 2. So input is going to be binary numbers and output is going to be reminders. So we have seen this problem long back where we have constructed DFA which accepts set of all strings which are divisible by 3. We can use the same one. So what is the shortcut for that? Whenever I say a number has to be divisible by 3, the number of states are 3. Let us say Q0, Q1 and Q2. Q0 corresponds to the state where the remainder is 0, Q1 corresponds to the state where remainder is 1, Q2 corresponds to the state where remainder is 2. Okay, and I have told you how to draw this. The shortcut is this: directly draw the state transition table, right, and fill it like this: Q0, Q1, Q2, Q0, Q1, Q2. Done. So this is the DFA which accepts set of all strings which are divisible by 3 in case if you have Q0 as the final state. Now I don't want that. I don't want a DFA. I want a Murray machine which should actually print the output, which is nothing but the remainder. If I am in state 0, then the remainder has to be 0. If I am state Q1, then the remainder has to be 1. If I am state Q2, remainder has to be 2. So the Murray machine can be constructed by adding the delta function. So if I am in state Q0, the output has to be 0. If I am state Q1, the output has to be 1. If I am state Q2, the output has to be 2. This is the state transition diagram for the Murray machine. Or you can even draw the state transition diagram, not the table, right? So instead of drawing the state transition table, how does the state transition diagram look like is, you will be in Q0, you will be printing 0. If you are in Q1, you will be printing 1. If you are in Q2, you will be printing 2. Reminders are that, right? And now Q0 on 0 is going to 0 itself, and Q0 on 1 is going to Q1, and Q1 on 0 is going to Q2, and Q1 on 1 is going to Q0, and Q2 on 1 is going to Q2 on 0 is going to Q1, and Q2 on 1 is remaining in Q2 itself. So this is the state transition diagram for the same question, and this is the state transition table. For such a question, whenever it is divisible by 3 or residue modulo 3, it is easier to go with this particular kind of state transition table. The reason is, you can even extend the question to even other levels. Let us say I want to extend the question like this: construct a Murray machine that takes all, instead of binary numbers, let us say I want to take all base 4 numbers, and that produces, instead of saying residue modulo 3, I can say residue modulo 5, right? So what should be the input? Input is all base 4 numbers. What are all base 4 numbers? 0, 1, 2, 3. And the output is residue modulo 5. So what are the remainders when I divide any number with 5? 0, 1, 2, 3, 4. These are the remainders when I divide any number with 5. So you can follow the ordinary method. What is it? When I divide any number with 5, the remainders are 0, 1, 2, 3 and 4. These are the remainders when I divide any number with 5. Let us say Q0 is the initial state, and what are the inputs? Inputs are 0, 1, 2, 3. And now you fill out the delta function like this. So what is the delta function? Directly Q0, Q1, Q2, Q3, Q4, again Q0, Q1, Q2, Q3, Q4, Q0, Q1, Q2, Q3, Q4, Q0, Q1, Q2, Q3, Q4. So this is same, the delta function is same, even though this is nothing but the transition table for a DFA which accepts set of all base 4 numbers which are divisible by, let us say, 5, or which is congruent to 1 mod 5 or 2 mod 5, 3 mod 5, 4 mod 5, anything. Only change is you have to add the delta function. What is the output? If I am in state Q0, the output has to be 0. If I am state Q1, the output has to be 1. Why? Because that is a reminder. If I am in state Q2, output has to be 2. Q3 output has to be 3. Q4 output has to be 4. You can take any example and you can trace it out, but I am leaving that as an exercise for you. Check it out. Okay, this is where I am going to stop.